Today we're gonna look at a course set on LeanPub that you can buy for free. The minimum price is free, called the Cloud-Based Data Science course set. And so this was generated by Jeff Leake's team and Johns Hopkins Data Science Lab. And it's a set of 11 massive online open courses or MOOCs. And the idea of this, I was actually involved in like a little piece of it. The idea of this set of courses was to teach people how to like do data science on a Chromebook. So that's why it's cloud-based, because we're using Chromebooks. Chromebooks cannot install software. And the idea was to help people like learn the skills to transition to data science, to get a job in data science that maybe would otherwise not have the opportunities to transition jobs into this field. And so the course is the course set is an introductory level course set in the sense that like everything is explained step by step. However, you'll notice that it's actually fairly advanced, and like the course goes over, for example, version control with GitHub, right? Which is maybe not something everyone expects in an introductory data science set of courses, because the goal was to teach people skills to work with data, to present data, to generate data reports that maybe companies need, things like that. And so there's a cloud-based data science, and there's also cloud-based data science plus, let's say. And so that is a version where like Ashley Johnson and other people listed here actually meet with CBDS Plus. We actually meet with individuals from these are they partner with a couple nonprofits in Baltimore, and so they're teaching high school grads this course, but like they need a bit more guidance, right? So they meet with them once a week, I think. Go over like what are the questions they might have, some of the where are they getting stuck in the exercises and things like that. So this is not really like, it's not a MOOC part anymore, right? So that's it's a bit more similar to a traditional course, right? Because you have actual like in-person sessions. But most of the courses and most of the material is already pre-recorded and available. And it's basically this set of LeanPub courses that we're going to go through. They were made in a way that could be automatically updated, unlike the Coursera courses that Jeff Leake and other people have done in the past. And this is using like an R package that allows you to incorporate both images that you have and text, and then make an automatic recording using a robotic voice. And so software for that was developed by Sean Cross, for example, and John Muscelli. So there's people in this team that have developed some of the software, people that have developed a lot of the content, in particular like Shannon Ellis and Abu Zar Haravan, who were both postdocs with Jeff, generated a lot of content. Ashley Johnson and Simone, they do a lot of the work interfacing with like local nonprofits and really running the CDBS Plus version. Okay, so that's the idea of this. And so because it's made by Jeff, right, it overlaps with a lot of the stuff that we saw in the previous week on the elements of data analytics style and how to be a modern scientist. But these are actually lessons, right? So, so it can be helpful for us, first of all, to learn some of this material, but also to ask people like, hey, can you can you go through this free lesson? Let me know if you have any questions. Did you get stuck in any of the quizzes, things like that. And so that way we can upload some of that teaching to this course. So if you've already bought the course, if you go to your library, which I can't see because of Zoom, library. Under course sets, that's like if you bought the full course set, that's where you'll have it. Actually, let me go to courses instead of course sets. Here we'll have all the 11 individual courses. And so I just bought this myself just to see how it looks. And so if you go to the introductory one, what I do is, for example, here on this link that says go to course, I just right click on it and open it into a new tab because I want to keep these main navigation for all the courses easily available for me. So let's say you open this course, right? And so once you open any of the courses, you can start the course, and that will launch a new platform from LeanPub for courses that has interactive quizzes and all of that. So that's what I recommend over like all the other download formats, which are like downloading a PDF or like Kindle software. So here we'll actually be using our browser most of the time. So I'll just click on start the course. And so the interface here has, you can download, again, the chapter, the particular course into PDF, etc. But what we see here on the main window, we see a set of text explanation, which is like, this is actually, like a lot of this is overlapping those previous books. But it has more specific examples, and it's more tailored towards education, right? And so here we can see like who is this program for high school students, people who are completing high school, student and community colleges, or adults who want to learn something new. But really, like I think a lot of these ideas, like let's say for example, a biologist at Liber wants to start coding a little bit more. Some of the ideas here could be really useful for them, or even for like people here in this team, right, who have been coding for a while. Some specific lessons might be useful then for them instead of like taking everything. Okay, so how is it graded, right? They have, you can actually get a grade if you want to complete the full course set. So there's a data science project at the end. There's going to be some short quizzes too. And you need to pass 70% of the questions to get the course correct. And at the bottom of all this text, there's going to be here a link to a YouTube video that has slides and text describing a lot of the same thing we just read, but like in a classroom setting. So let me just play one of those.
Hello and welcome. This is the first class in the cloud-based data science series. The goal of cloud-based data science.
So I'm just gonna pause it. I don't know if you heard the audio, but like that was a very robotic voice, right? And so that's actually using like some Amazon's. Amazon has a service where you can give it some text and it will make the voice for you. So it's using one of those voices, and then at the very bottom, there's two more links. There's one for slides, which will open in a new tab. There's like the Google slides that actually are the ones using the video, and you'll notice on the bottom of it there's text. So that is a text that the robotic voice will read for you. So this is actually like more accessible, right? So like the video can have subtitles if you want. and so it can be used by more people. Okay, so yeah, so that's the structure of the files, right? And one last thing is the quiz. It's here says like, oh, take the quiz. It will be 3 points. And so that quiz, if I scroll all the way up, on the left side, it says here there's 14 lessons, 10 quizzes. And so this is actually maybe not as intuitive, but like the headings here, for example, welcome to cloud-based data science, those headings are the lectures, right? So I can click on some of them, and that will change me to a different lecture. The quizzes, though, are the subheadings that have like this clipboard with a check mark and an X and a little X box at the end. So the quizzes look like this. They will look different for everyone, right? Because they actually have like a bit of a random setting there. That way you can just copy. Although like if you do it like many times, I think you can figure out the answers, right? So the quizzes are fairly short. A lot of times, like they're basically like ways to double check that you read the lecture and stuff. Some of them get a bit more complicated. Okay, so if I step back a little bit to the courses, let's look at all the courses in this course set. So let me close this one here. All right. So what are the courses? So the first one is like what are they trying to achieve here on this cloud-based data science? And so sorry, I forgot to mention each of these courses. The idea is that they can be completed in around a month for someone that is working like part-time on this, or and faster for anyone like working like full-time. Okay. So the first one is like, what are they trying to achieve here? Like, why is like data science like important to learn? And then also a bit of like using the Google, getting like what is a browser, for example, right? Like, I mean, all of you are already familiar with that concept, but not everyone is, right? Not all the target audience for this course set is familiar with a browser, right? So setting up your Google account, all of that. There's Google on the cloud. So this will be like setting up your RStudio cloud account, which I'm not sure you know about, but that's a relatively new service from RStudio, and that like they run some machines on the cloud and give you RStudio server instances that you can just use. It has a bit of other extra features beyond the native RStudio. And so, for example, they use it here as a way of them making classes that then the students here can use and like change their code and whatever, play around with the code from the class. So organizing data science projects, that's a lot of what we talked about with like what they forgot to teach about R with like Jenny Bryan and other people. So they actually have an image of Jenny Bryan on this course. Version control is about like using Git and GitHub, and really just the basics of it, of like Git pushing, Git pulling, and a little bit of like branches, but like they don't, the idea is not to get it too complicated too fast. So this is mostly about like how you want to be using version control, and it's basically what we do for our work. A lot of that here. And so it's only until the 5th course that they start using R. And so they have an introduction to R that is a bit more practical than other introductions to R. So it's a bit more like, here's the data set, let's start like looking at it, start playing around with it a bit. Data tidying, then that is like, what is a tidy data set? How can you make it? and it's quite linked to the next course, which is data visualization. And data visualization has lectures on like learning about ggplot2, learning that syntax, customizing some plots, and making those plots. Now this was like a course that was done on the web, right? And so the people taking this course the people taking this course don't necessarily have data sets of their own already. So then there was a chapter or a course on like getting data from the web that could be useful. And then there's one on data analysis. So there's a little bit of statistics here. This is actually maybe one of the longer ones. And it ties back into like data tidying and data visualization. Then the idea was to train people such that they could then get jobs in data science. So then there's 2 more chapters or sections of the book related to that. One of them is like writing and presenting your results, because that is like a skill that is very useful to have in the world of data science. And so there's actually here a chapter on like writing a blog post that will look a little bit more into that. Or tweeting Twitter in data science, for example. There's a full lesson on like do's and don't do's of Twitter. And then getting a job in data science is about like writing your cover letter, practicing the. A lot of companies, I forget what they have this set of exercises, exams or interview interview quizzes. I forget what's the name. Sorry, let me go to the course. Oh yeah, take-home data analysis. That's the term that a lot of the companies use. So a lot of companies will basically do a test for you, right? And they want to see like you have the skills for analyzing data and stuff. And so there's a lecture here on like what to think about and what you should do for some of these exams, right? That they're gonna have you do. Right, so there's quite a bit here. Let's see how long this video is. 12 minutes. Right. So this is a lot of like useful information, I think, for all of you, but also for the people that we're going to be helping. Let me go back to my courses. Right. So let me pause and see if you have any questions. All right. So, ouch. So some of the things that I think it'll be useful for you to do is like go through each of these courses, right, and like just open them. For example, here I'm going to open the version control one. Start the course. And so a lot of times I'm just like scrolling quickly to see like what images they have and stuff like that, right? Because some of these images and like that type of material can be useful for like when we're explaining concepts to other people. Right? So for example, let's look at here, cloning a repository. So that's a full lecture on how to clone one. And so it has like screenshots to the GitHub interface, although as you know, it recently changed, but not that much. A lot of these buttons and stuff are still there. And so this set of the slides or images can be useful for explaining. So I'm just going to open the slides. So they did a lot of work, right? Like trying to create intro data science educational materials. But like, as you know, this step can be really confusing, right? And like there can be like a lot of errors related to it. So just understanding like what are the concepts, how they're related and stuff, right? Is useful here. So that's one of them there. Version control. There's like, it ends with like setting up a project on GitHub, like creating a repository, and then like linking that to your RStudio Cloud account, which I believe all of us can make one for free on rstudio.cloud. Right. So version control, introduction to R, things I think we're mostly familiar with. Also like an like even in the introduction to R1, some of the concepts here can still be really useful for us. So I'm forgetting where it was, but it, or maybe it's in the organizing data science projects, maybe. Let me see. No. Using passing code. Oh yeah, so here, for example, using passing code, that's where they talk about the here package, right? I mean, we've been seeing that name all over the place, right? But this is like a different way of learning about the here package, and maybe a set of steps that will be more accessible to people than like what they forgot to teach about our workshop, right? So there's a lot more images of like, okay, this is where we are, this is the image that we're looking at, right? So let's say we're in raw code and the desired location is the project figures exploratory, right? So like that would be the specific relative path, but how can you create it? Things like that using here. So those slides can be useful there. So what I want you guys to do is to open the introduction to R1, and let's go through one of them. So I probably actually won't record this, but what I want you to go through is the writing functions in R lesson. And so yeah, like let's read through it or watch the video, and then let's complete that that little like the quiz at the end. So the quiz here is going to have like a couple questions here. I guess each of us is going to have slightly different questions. So let's spend some time like going through this one. And I want to go through the writing functions in R because that's going to be tied to what we'll be doing later in the week, building tidy tools. Because you need to know how to write R functions before building R packages. So yeah, let me stop recording. All right, so this is like 18 minutes later or so. So just to recap a little bit this chapter, right? They introduced the concept of a function and what they call a user-defined function instead of a function defined by an R package or R itself. They explain when you should write a function, why it will be useful for you, how to do so, right? So there's actually, I like this bullet point here, the name, arguments, and body, and how that actually translates to our code. Then there's a section on how you should think about naming your function. And so they reference a function here called SS, which is a bit funny because we actually have a function called SS in the Jaffe Lab package that was defined by, I think that's a function Andrew Jaffe took from Rafael Irizarry. So a different way of thinking. But I do like the way of using verbs and things like that. And a lot of this is about thinking about the humans that will be using the code, not the actual machine. Then they explain function arguments, and they make a claim here in bold that's actually correct. But later on, they explain a bit why they actually made that incorrect claim initially. And it makes sense for the purpose of teaching what a function does, not to dip into all the all of the exceptions that are possible and stuff. Then they talk about like, okay, like if you want other people to read your code, you should comment it in the future, how to do so, what is the output that you get. And so they talk about a special function used inside of functions, which is return. There's also another function, a special function that is used inside of functions called break. That one is useful if you're using like a while loop, for example. You can always break that while loop. But you might also want to use message, warning, and stop. And so further below, well, sorry, I'm getting ahead of myself. So then they go through a full example about converting units of temperature, Celsius to Fahrenheit, how to do so, how to run your function, and then how to prove it. So here they start using the return argument with like, they add a little text here. Then they add like, okay, let's add more than one argument, for example. So they add the temperature and the unit arguments, temp and unit, which I actually thought of you would get an error here when you run it. I thought here like that if you run this function with like unit equals, let's say, hola, you get an error because but actually guess the output of message is null, which I hadn't thought about that assigning the output of message to an object gives you null. And you can see that, for example, here when you run the function and you use an incorrect input value for the temperature, you get the message that they wanted you to get, but then you get a null output. And that's because the output of message was also null. And so at this point, you might actually think of like, instead of using message, it might be more appropriate to use stop, which is a function for prompting errors. And so that, you know, this is something you have to think sometimes about, like when you want an error, when you want a warning, and when you actually want just to provide information to the user and have your function run correctly. Some things they don't go into this, right? And that's understandable. Is like they explain like setting the default of an argument. So here they're setting the default of unit to the value C, the character C, capital C. But you actually here when you set the default for an argument, you can actually have valid R code on the right side of the equal sign that uses the rest of your arguments. So like the default for unit could have something to do with the input for temp. And so I use this quite a bit in some of my own functions. All right. So, and then there's a little quiz, which I already took, and you can retake multiple times. So, yeah, do any of you have questions about this? Writing functions. Are you masters of writing functions now? Yeah, cool. So let me pause the recording and let's take a break. All right. So there's quite a bit of like useful things here and there in these courses for you guys. Also, like, I mean, definitely like a lot of things for people we're going to be helping. But one of the things I wanted to highlight is under the data analysis course. Let me open that one. I'll open it in a new tab. Start the course. There's a chapter here about translating questions to data science questions. And so this, I think, is like a lot of our role too, right? So let's say we're in a meeting, right? And sometimes people might be asking like biological questions. And so we need to find a way of translating those biological questions into actual data projects that we can carry out, right? And so this is a chapter that I would highly recommend you guys read a bit more, but that we won't do right now. And so this is, you know, something that we need to be conscious about. And so there's actually a great example here from David Robinson. David Robinson was a PhD student with John Story at Princeton University. John Story was Jeff Leake's advisor, PhD advisor. And so he's kind of like my academic grandfather, John Story. And so, I mean, David Robinson and I were like students at the same time. He graduated a bit before. And if you go look at him on Twitter and stuff, he's like super popular because he does a lot of live coding sessions. So he does every week a Tidy Tuesday live coding session for an hour. And so he's incredibly fast at coding and knows a lot about the tidyverse and stuff like that. And so if you just want to learn a bit more about like advanced data munging with R every week, his YouTube live sessions are great. I've only seen a couple, but that's because I don't have as much time. But yeah, so this is a great chapter here about like translating a question into a data science question. So I'll leave that for you guys to do. Writing functions. All right. So I'll jump to getting a job in data science. And if I open that course, let's start the course. There's a couple things here that I thought could be useful for you guys, even if you're not like actually looking for a job right now. Like for example, there's like the part about improving your GitHub profile, just to make it a bit more explicit about who you are and things like that, right? So that you basically like take advantage of the bio field to describe a little bit about who you are and to point people to the main website that you want people to be looking at for information about you, right? That could be like your LinkedIn profile, maybe you have your website, maybe it's your own Twitter account, whatever, right? And so this can be useful because a lot of the things we're doing are code-wise, right, on GitHub. And so if people want to find more about you. So let's say, let's look at spatial reliability, for example, right? So if someone comes here, right, they'll notice on the contributors, there's 5 contributors right now. And so they might be like, okay, let's find out more about Leo, right? So they might open that in a new tab. And so here, right, there's more information about me. This information I want to highlight myself, right? And so I'm pointing people to my GitHub, my website, right? Let's look, for example, at Brenda, right? And so Brenda here is like, oh, I'm an undergrad student, but there's no like website or stuff, right? Although she does point to her Twitter profile, which is, a pretty good, like, if as a way for, to tell people like, here's more information about me, right? This is how you can find more about what I do and stuff like that. So this, that is useful to look at. But then using Twitter for data science, this is a chapter I wanted to highlight because I know it's of interest to several of you. And like it talks about how to actually make an account, but then it also highlights that your profile description, right? Like these are some examples, and all of these examples here are using either hashtags or other Twitter accounts, right? And so that actually makes it a bit faster for people to find you. Because you might mention the name of where you're studying and stuff, but you actually have like a hashtag or stuff that can make it a bit easier for people. And then you could also highlight your main website again, right? So again, if you're trying to get your name out there, right, you want that first impression to look good, right? And so not everyone, but some people will be curious to learn more about you, right? And so that's one of the things you can do. And then the next thing is this set of slides uses talks about Mara Averick, on Twitter known as Data and Me. And at the very end, on the additional resources, there's a talk by Mara who she presented at RStudio Conference 2018. A short presentation. It was like 20 minutes or so. And I mean, I saw this video a while back, and I found it really useful because it talks about how to actually make how to communicate through tweets, and she uses GIFs a lot too. But how to get like people to like what you're sharing and stuff. And so this is a very specific type of Twitter use when you're trying to be a curator of content, right? And you're trying to say like, oh, this is what I thought was interesting by other people. And so if you're doing that, or if you're promoting work by others, right, then that talk is pretty good there by Mara. Right. So let's do another session. I'm trying to move this Zoom thing. All right. So I'll go back to the course number 10, written and oral communication in data science. And I'll start this. And so I want to go through a particular lesson here because I think it's going to be useful for what we're going to be doing. So there's one, like, for example, about how to write a blog post, which could be useful for all of us. But the one I want to go through in more detail is this one, how to have a one-on-one meeting. So what I want us to do is to like go through it, and then we'll also like discuss what everyone thinks about it. So I'll start recording for now. Hey, so I found this useful, and it could be a great way to also diffuse conflict if it arises, because then you can point to the specific chapter and tell people, well, I'm following this specific advice, thank you, right? Things like that, instead of saying like I just came up with this idea out of nowhere type of thing, right? Um, and so that's I guess on the latter part of this chapter, the conflict resolutions. So um, this this lesson talks about consulting and how that will look like a bit, but then also what to expect. And so part of what we expect here is that yes, both people are going to learn from each other. Um, um, and so you have to try to remember that like they might not know all the acronyms and you might not know everything they know also, right? Their acronyms and stuff, or the biology. And so it's always great to ask about the other person to try to explain more slowly something, and for you also to spend time trying to explain the analysis or the software or whatever in different ways. And so a big component of it could be this step of the investigation, which is like figuring out what they have, what they want to do, what are the questions they have in mind, what is the data they have, any constraints and things like that. And so I suspect that a lot of the meetings might be on this venue, and a lot of the initial venues. So let's just try to figure out what is this person interested in, right? And so potentially this is also like where like on the data science guidance sessions, they might meet with me first, right? And I can help out, tease these apart, and then try to assign them to someone that will know a bit more of the specifics that they need, right? Of the particular, let's say, software or whatever that they need. So there's going to be parts about the question, the prior knowledge, and the data. And so a lot of it is also like, do you have access to the data? Were you given information about the question beforehand? And so we're gonna require people to give us information about their question. And so that's part of what I'm gonna document on the data science guidance sessions, such that whenever people ask us for help, we'll have some, minimal information that we can work from. Some of the things, for example, about the limitation here are like they can get more specific into the statistics, right? And so, like, I understand not everyone here has like a statistics degree, right? So you should remember that it's always okay to say like, oh, I don't know this. Maybe someone else in the team knows this, right? So that is okay. This checklist over here I thought could be quite useful, about like a bunch of different questions that we can try to keep in mind, and try to clarify whenever we meet with someone, right? Not all the questions will apply to every single session, and like, for example, let's say someone has trouble installing a specific piece of software, then a lot of these questions about like, is the data available in a tidy format, right, don't apply right at that point. But sometimes like people that have questions about like, oh, I have data and I want to make a plot, then in that particular case, whether they have the data in a tidy format will be really important, right? Because that's how you can then easily make some plots. And so sometimes our job will be recognizing what people need to do to make their data a bit more tidy, stuff like that. The assigned responsibility here, right? So we won't be doing data for analysis for other people outside of the data science guidance sessions, right? So during a session, we can definitely like have a hands-on approach and try to like fix the problem, right? Like write some code and stuff. But then after that, the idea is to tell people like, okay, like I think you should try X, Y, or Z solutions, right? And in particular here, it might be important to remember to remind people like, oh, you should definitely try like X solution before we meet next time, right? Because otherwise, next time they could meet, then like let's say a week has passed, and they're at the same point than the previous week, right? And so you want people to try things, to give you more information between each meeting, to make sure that they are advancing. So we'll definitely have follow-up meetings, right? And so we won't actually report much on what we've done unless there was a specific question in the previous meeting that we didn't know the answer to, right? But it will be mostly us asking people like, what have you done since last time, right? What are the new questions you have? What can I help you with? More than us reporting what we've done. So this section on common pitfalls I thought was really useful because a lot of times, like, yes, there's different backgrounds, different skill sets, different personalities, and so they're all of those are sources of potential miscommunication between people, and so we'll assume the best of people, right? That they that maybe we just need to be like a bit more careful and like say like, oh, can you explain this again? Can you make sure that that the advice I gave you is being used correctly, right? That it's not being misinterpreted, things like that. So I mean, I thought like some of the ideas here were useful. Then, like if we were analyzing data, data might not show the desired results is a big one, right? And so that's where the data ethics summary here from, I guess, the previous lesson is important to remind ourselves that the process is what matters, not the result of what we're doing, right? So that's why, in a way, we put in a lot of time and effort into learning like what they forgot to teach about R and like the RStudio oriented projects workflow, right? And things like that. And so we all make mistakes, right? And so like definitely maybe the data is not showing the results that people expected because maybe there was a mistake in the model. And so like it's always valid to say like, oh, like let me that's okay, like maybe the data is not showing what you expected, let's double check the model, let's double check that everything is correctly specified, things like that. But once we check, right, then it's like, okay, like I mean, this is what the data is telling us, right, at this point, right? So like we shouldn't advise people to be like, oh, you just change your p-value cutoff, right? That type of thing. That's, I don't know, right? So that's what I thought was interesting. So I'm gonna stop the recording here, but like,